Okay, the DOM. So, coordinate plane, 2, 11 pi over 6 would have put you here. Negative angle flips you over the x-axis. Negative radius flips you around the origin, which would have put you here, which was the correct answer. Third quadrant, the equivalent to 210 degrees. All right, if you'll please pass those up in your rows. Maybe I'll be so lucky as to have Kyle help me pick those up. Awesome. And then get out your notes. We're going to do 6-6 and 6-7 today. Monday we're going to review for your final. And Tuesday will be your final, midterm. I meant midterm. Here we go. Vectors. Vectors are mostly used in navigation. Pilots and captains use them. That's what we're going to be talking about today. Very similar to polar coordinates, except vectors actually have a length. They're the actual segment connecting that. They have both length, or they call it magnitude, and direction. Two vectors are the same if they have the same magnitude and direction. Now, I told you it's all about like used in navigation, primary place they're used. Well, by that definition, two vectors can be the same. Like, let's say, I know this probably isn't the case. Let's say you took a plane from Portland to San Francisco, and you took a plane from New York to Nashville. Now, I know these probably aren't the same. But let's say they had the exact same heading and they were the exact same distance. Even though they're in two different locations, those vectors would be the same. Let's say they both went exactly 200 miles at 10 degrees south of west or something, blah, blah, blah. The exact same direction and magnitude is what dictates a vector being equal to another vector. So on this one, it tells you they have the same direction, that's half of it. Do they have the same magnitude? And then therefore, are the vectors equal? When you're finding the magnitude of a vector on the coordinate plane, it's essentially the same as finding the length of a segment, which we did using what formula? Distance formula, that's right. So, distance formula is what you're going to need on the first problem or two. x2 minus x1 squared plus y2 minus y1 squared. So, for the first vector, vector u, that little double absolute value means magnitude or length. We're going to find the length of u. Let's see, x2 minus x1 squared plus y2 minus y1 squared. 5 squared, 4 squared. So is that square root of 41? Yes, it is. This one's much simpler because it's starting at the origin. You can just count. This side is 5, this side is 4. Pythagorean theorem. And this is also square root of 41. Are my vectors equal? Yes, they have the same magnitude and they have the same direction. Therefore, they are equal. Now, let me tell you this. Let's look at this one, where it doesn't tell you that they're the same direction. If this arrow was over here instead of over there, these aren't equal. Because even though they're parallel, one's going west, the other's going east, that's not the same thing at all. But because the arrows are going the same direction, do they have the same length? Yeah. If they're perfectly vertical or perfectly horizontal, don't reinvent the wheel here, just count it. They're both 6 units long. They have the same magnitude, same direction, so yes, they are equal to each other. That's what you have to do for the first ones. A little distance formula, a little counting, maybe a little Pythagorean theorem. True. Very true. Yeah, if you want to do it like that, absolutely. There's a lot of ways. Somebody asked me last block, can we eyeball it? And I said, yeah, if you trust your eye test, absolutely. You don't have to distance formula as long as you know what you're looking for. But I'm not going to say that there won't be somewhere down the line. I'm not promising this. I haven't designed this or anything. Where they may look exactly alike, but may be different by like half a unit. So if you're going to use the eye test, you may fall prey to one of those. But it's usually pretty straightforward, and you can see it. Okay. Sketch a vector and find its magnitude. Well, I's and J's, these are the horizontal component and the vertical component. And they work exactly like a coordinate. I's are horizontal, J's are vertical. So, positive 3i. Positive 3 on the coordinate plane goes right or left? Right. So that's right, 3 little units. Up 1 unit. So here would be your resultant vector. You have drawn this vector, vector v, which has a little Robin Hood cap. That's what vectors have. 3 to the right, 1 up. Now it wants the magnitude. Thank you for the laugh, by the way. Magnitude. When it gives you the i's and j's, it's just Pythagorean theorem. That's 3, that's 1. You can always just take the numbers. So 3 squared plus 1 squared equals c squared. Solve, and you should get the square root of 10 is your magnitude. I put c squared just because I'm used to Pythagorean theorem. And that was number 5. You mean like a nice whole number? Yeah, possibly, probably. I can't guarantee that, but let's look at number 9. Am I going to go left or right? Left, 6, because it's negative. Am I going to go up or down? Very good. So here's my resultant vector. Vector v again. Pythagorean theorem. Now, if it makes your soul feel better, you can use your negative numbers in the Pythagorean theorem, but what's going to happen when you square a negative number? So I just like to cut out the chase and just jump straight into the positive numbers in the Pythagorean theorem. You can use the negatives if it makes you feel better, but it's going to be the same thing, and I don't like an excess of negatives if I don't need them. So 36 and 4, square root of 40, which I think reduces to 2 radical 10, is the magnitude of vector v. Today I don't really care, but on your test, just know that everything's going to be reduced as far as possible. So if you don't, you may have to plug in things that equal and see which one. I don't guess I care today. If you put square root of 40, I'm not going to mark off. I'm really more interested in that you know the theory. Although I will say I have been taking a lot of points off lately because people have been rationalizing on quizzes and things, and on that one that we had. So, questions about something from this slide, about where I got a number, what you're asked to do, anything. If it gives you the i's and j's, yes. Now, what about this one? It's 0j. You could punch it in the Pythagorean theorem, 4 squared and 0 squared, but here's the thing. Remember that one just a second ago that was straight right? You could just count it. If it's just one component, that number is going to be the magnitude. There's nothing else to take into account. This one has a magnitude of 4. That's how long it is. If it was 384j, 384 would be the magnitude. If it only has one letter, the positive of that number has to be the magnitude. So, I mean, that doesn't make sense. By all means, do Pythagorean theorem, but you should get square root of 16 as your magnitude when you do it. Questions about anything on that board? All right. All right, let V. Every vector has a starting point and an ending point. Now, my example earlier was Portland and San Francisco, or Nashville and New York. The whole reason for the arrow on a vector, unlike array, is not to show that it keeps going, it's to show what direction it was going in. So we call the arrowed side the terminal point, where it terminates. And we have the starting point of a vector is where it initiates, or its initial point. Well, let's draw this for a second. So this one has an initial point of -4, shabam, and a terminal point of 6, 2. So if I were to draw my vector, that's what it would look like. How can I find the i's and j's of this? Because that's what it wants. Yeah, if you graph it, you could just count it, you know. 1, 2, 3, 4, 5, 6, I believe it's 10, and then up. But how's a way you could do it using the coordinate? Well, we're not looking for the length. We're looking for the horizontal and the vertical. What? Essentially, yes. Essentially. I just need to find the difference between x2 and x1 and y2 and y1. Your I value is going to be the difference of your terminal x minus your initial x, and your j is going to be your terminal y minus your initial y. So, let's do the x's first. 6 minus negative 4 is what? 10. So 10i. 2 minus negative 4, 6j. And there is vector v in terms of i's and j's. You just subtract the x's. It's just important that you use the terminal point first. If you accidentally switch up the order, you're going to change the whole direction of your vector, because it'll make something negative. So make sure you always subtract terminal minus initial. TI, like the calculator. I believe all it asks us to do is find I and j, so the graph is completely optional. In fact, I wouldn't even bother doing it. But I wanted you to see that if you forgot that formula, you could always plot it and count the spaces. Is there another one on this board somebody would like to see more than the others? I want to work one more. Which one would you prefer to see? 17. All right. The I value is going to be the terminal x minus the initial x, and the j value is going to be the terminal y minus the initial y. Negative 7 minus negative 1 is negative 6. Negative 7 minus 7 is negative 14, so that's negative 6i minus 14 Java juice. Questions? Okay, let's keep going. All right, these are, if you were to look at this and think, man, wouldn't it be nice if this is all you had to do? That's all you have to do. U plus V, you literally add like terms. U plus V, 2i plus negative 3i, negative 1i, negative 5j plus 7j, 2j, done. No problem, just give me 2 seconds. Make sure there's no problems on that one yet. I'll take your 37 and I'll raise you a difficulty. Let's do that same kind of thing, but up here. That way we're doing everything at once. 3 times v. So you're literally going to take 3 times vector v. So that's going to be negative 9i plus 21j minus 4 times w. So that's negative 4i. Oh, well, I left out my minus, but I like what you're thinking. Minus 24j. Now I need to subtract them. Negative 9 minus a negative 4, so negative 9 plus 4, negative 5i. 21 minus a negative 24, so it's 21 plus 24, 45j. Now the only thing that's left, I need to find my magnitude. A squared plus b squared equals a ginormous number squared, and you know how to finish that from there. Yeah, that's all that means. Now, you may be thinking, why on earth would you need to add a vector? What does that do? You know, I said vectors are used in navigation. Well, let's say you took an airplane from New York to Nashville and then took a plane from Nashville to Maryland, right? So you would have gone like New York to Nashville, Nashville to Maryland, and if I asked you, where are you now? How far have you come from where you started? This would be the answer, wouldn't it? That's really as far as you've traveled total if you were to add everything up. That's your displacement. When you add or subtract vectors, that's what you do. If I said, this is vector u and this is vector v, what is vector u plus v? You would go to u, you would do v, and what the resultant would be u plus v. Let me show you an example of that. Now, I'm not going to make this, you're not going to have to do that today, but eventually you're going to get in a class that deals more in depth with vectors, and you need to know what's going on there. So let's look at just 21. Keep it simple. Well, let me get a rough sketch coordinate plane going on here. All right, we'll start at the origin. Vector u takes me 2 units right, 1, 2, and 5 units down, 1, 2, 3, 4, 5. Bam. Vector v from there takes me, because I'm adding it, when you add vectors, you start where the last one ended. Takes me 3 units left, 1, 2, 3, and 7 units up. Well, that's 5, so up another 2-ish. Bam. How far have you gone total? You've gone this far. Now, if you actually added those vectors with their i's and j's, what do we get? Minus 1 plus 2j, minus 1, 2j, over 1, up 2. So that's what it's representing when you add and subtract and do all that stuff to these vectors. Any questions on that? Oh, that was a few minutes ago. We actually literally added like 2 plus -3, -1. -5 plus 7, 2. And I was just showing this is what that would look like. This right here? Yes. Only reason I showed you this is so you would know what it looks like, so that whenever you get into class that does more graphing with these, you've seen it before. Because, I mean, it's not horrible. It's different. That was number 33. Because it asked us, well, I changed that problem because I was trying to find the hardest possible thing you would see. So I took this problem and then I found the magnitude of it. So first thing I did was add, or did that part, which is where this came from. Then I found the magnitude using my a squared and b squared. Well, if it has a double line, you will. That one originally, the way it was written, no, you wouldn't. But like 37, you would. That's what those lines mean. Other questions? These are good questions. Ooh, I love days where there's lots of good questions. Thinking is of the essence. Don't mock me. I know you want to. Okay. Unit vector. Here's the deals behind this. Let me go back to a nice drawing of a vector. Take this vector, right? We know it's broken down into like 10 little horizontal components and 6 vertical components, right? Well, you could also break it down into individual little unit vectors going up in this direction, which have a length of 1. Well, if they have a length of 1, I'm still interested in like how many little i's and j's are made up of that. So to find the formula for one unit vector in our direction, you need this formula, which is actually very, very simple. It's basically your vector divided by your magnitude. Just your vector divided by your magnitude. Which may sound complicated, but it's actually quite simple. So v over magnitude of v. That is the unit vector formula. That's how I would write it. I don't even know why they bother telling you it's a non. If you have a 0 vector, that's completely pointless. That's like taking a flight from Nashville to Nashville. Or not even leaving the runway. Okay. So, finding a unit vector. What is the magnitude? Where are my magnitude gurus? What's going to be the magnitude of 41 when I plug that in the Pythagorean theorem? You guys are wicked smart. Alright, so I'm going to take my vector divided by my magnitude, and you just break that down. 3/5 I minus 4/5 j. And there's the, or you can do decimals if you want. And that is the formula for one unit vector. It seems kind of pointless to look at it like that, but nonetheless, that's what it's wanting when it asks for a unit vector in the same direction. You take your formula, divide it by your magnitude, and reduce. Hey, it's my name. because this is an online textbook and it's showing who rented it. Me. The app, that's a 5. That's the magnitude of it. The magnitude is 5. I had some of my, somebody found it for me. They did Pythagorean theorem, a squared plus b squared, and found it. Yep. I know you're thinking, why can't we just leave it like this? Because in vectors, it's kind of important to separate the i's and j's. That's the only reason we break it up. Algebraically, it doesn't make any difference. But, you know. All right. Well, it is now. Thanks for bringing that up. Doesn't matter. Okay. 75 to 13, I think. I'm just kidding. Okay. Now, this one. Anytime you have a straight horizontal or straight vertical vector, it's really simple. Because the unit vector, wait for it, bang, I. If it was minus 212j with no I value, then you just have some ridiculously long vector going straight down, and one unit of it is just negative 1j. That's right. If you just have I or j, you'll have to keep the sign. This was negative, that's negative. But just one of those is going to be your unit. There's no other piece to divide by. There's nothing changing your magnitude. So if you have just one unit, whether it be I or j, then a unit vector is just going to be that unit, 1i or 1j, positive or negative. For that one, yeah, for this one I drew down here, it would be negative 1j. We'll look at just one more of these real quick. How about 45? Here's the thing. If you're more than welcome on 39 to actually work it out. And, you know, if that's not quite clicking with you, 6i, your magnitude is 6. There it is. And you're welcome to work it. But you're going to find that shortcut prevails. Oh. Yep. You got it. 45. What's my magnitude? Square root of 2. Remember, it's 1 squared plus 1 squared equals c squared, so it's 2 equals c squared. Let me just write it out. 1 squared, therefore square root of 2. Now, when you do the unit vector here, you run into a problema. I plus j over radical 2. What's the problem with this? Beautiful stuff. Very good. You have to rationalize it. And how do you rationalize? And what is radical 2 times radical 2? Thank you. Not 4. People are putting 4 on stuff. You're getting counted off for algebra mistakes. Don't do that. So you have I radical 2 over 2 plus j radical 2 over 2. So that would be the answer to 45 right here. Questions from that slide? The only other slide left on this lesson, and we're going to do them back to back. The only other slide left on this lesson is the one we did yesterday. Now I'll do one example using very minimal explanation, but people are still writing, so that's cool. Love it. All right. So they give you the magnitude and the direction, and they want you to find the i's and j's. This is exactly like converting polar coordinates to rectangular coordinates. You're going to take, let's look at 49. You're going to take your magnitude, cosine of your angle equals your I value, magnitude, sine of your angle equals your j value. Make sure you're in degree mode. Somebody punch those in for me, making sure you're in degree mode, please. getting the feeling that nobody's punching this into me. Now it's a race. And the second. Oh, they're both negative 8.4. So, ooh, you're just trying to one up Kyle? Is that what it is? Because he beat you? Okay, fine. 8.5. Negative 8.5i minus 8.5j. Magnitude cosine theta gives you your I. Magnitude sine theta gives you your j. And I explained why yesterday. So we're just going to skidly-do right on as soon as you write down that example in your notes. Plus, yeah, normally it's plus, but since it was negative, we just changed it. You could do plus and negative if you prefer. All right. Now, rather than go ahead and give you the assignment from this section, I'm just going to jump straight into the next section because it doesn't take very long. Close. It's over. 6.7. Obviously, we're not going to do the done. Only reason I made this done, by the way, is because as you just saw from your midterm, there is going to be one or two of those on there. But you can look at that on your own time. You need to write down this here formula, although it's quite simple to remember once you get going with it. The dot product of two vectors is going to be logically speaking, it's going to be baffling to you because the entire section that we just did, vectors are always I, j, two numbers. But the dot product of two vectors is one number. Because it's not a vector that it gives you. It gives you a number that's going to help you determine the angle between two vectors. Like those classic problems you've seen on every ACT or SAT or anything you've ever taken that was standardized. Two trains leave a station, one going east, the other going southwest. Blah, blah, blah. This is classic one of those, because two vectors starting at the same point, going in different directions, and this is going to help us in a moment, after we practice finding just what that is, it's going to help us find the angle between those two vectors. But when you're done finding a dot product, it's just one number. You just take the coefficients with your i's, multiply them, take the coefficients with your j's, multiply them, and then just add it together. Let's look at one. Number 3. Let's look at number 3. V dot W. Coefficients of your I values. 5 times negative 2. Negative 10. Negative 4 times negative 1. 4. So your dot product is negative 6. Just a single number. That's really all there is to it. There's like nothing left to do. Now V dot V, you'll just multiply V times itself. So let's cross this out. And we're going to be multiplying V times another V. 5 times 5. 25. Negative 4 times negative 4. So our dot product is 41. Well, it wanted V dot W, which is negative 6, and V dot V, which is 41. Whoa, what? Wait, the dot, just the dot. What do you mean? It is. They call it the dot product. I don't really know why they call it that. But just remember, when it asks you to multiply vectors, you should just get a single number. You won't ever have to like distribute or anything, because i's and j's are like completely separate. You're multiplying the coefficients of the I, and you're multiplying the coefficients of the j, and then you just add them together. Yes. Let's see. We're going to be doing a lot more dot products, so we'll come back to doing one of those. if you're asked to find a dot product of one of these, I think it's easiest if you write it out with a 0 as the other one. That way, your dot product is a little easier to see. 5 times 0, 0. 0 times 1, 0. So that one has a dot product of 0. That was number 7. I rewrote it with 0j and 0i. That way when you go to multiply your coefficients, it's easier where they're coming from, to see where they're coming from. Now, let me ask you this. Think about 5i. That just goes straight right, correct? 1j goes straight up, right? What angle is formed between those two vectors? What kind of angle? Yeah, a right angle, 90-degree angle. You're going to find, and I'm kind of jumping ahead to the very last slide of the day, when you have a dot product of 0, and it won't always be this cut and dry where one's only i's, the other's only j. When you have any pair of vectors has a dot product of 0, that means they are perpendicular. Remember how I said dot product is going to help us find the angle between vectors? Well, in about 2 slides, I'm going to give you a formula that's, it's not horrible, but it's a rather lengthy formula. But if you ever find that the dot product of 2 vectors is 0, stop. You don't even have to finish the formula. You'll know the angle between them is 90 degrees. So that's kind of handy. You might want to remember that. 0 dot product equals perpendicular, which actually, vocab word of the day, I guess. Vectors, all of these are 2-dimensional vectors, but in the very near future of your math careers, you're going to get into 3-dimensional vectors. X, Y, Z, and they're going to come out. Well, now things can be perpendicular in any number of ways. Perpendicular, 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 right? So in 3-dimensional space, they don't call it perpendicular. They call it orthogonal. Okay? In fact, I'm going to go ahead and jump to the last slide and show you that. We'll come back to this other stuff. Use the dot product to determine whether the 2 vectors are orthogonal. That just means that they're perpendicular. So all you'll have to do here is literally multiply them. If it's 0, they're orthogonal. If it's not 0, they're not orthogonal. And that's all you have to do. So let's look at like 25. 2 times 4, 8. 8 times negative 1, negative 8. Add those together, what do you get? Are they orthogonal? Yes, they are. They are perpendicular. Anything other than 0, and the answer is no, they're not. None of, yeah. All of these are 2. They're only using orthogonal. I mean, technically, because it's only 2 dimensions, they could have very well just said perpendicular, but I think they're just trying to get you ready for that in the future. Yeah, because technically orthogonal doesn't make any sense in this regard. You mean in the navigational sense, like the examples I've been using? Maybe not. On a graph? I'll tell you what, that's a side conversation. I don't want to confuse people since we're not going to be doing that today, but I'll tell you, as soon as we're done, I'll come over there and talk to you about it. Okay. So anyway, backtracking. We've now done the first and last slide. The second slide, just the exact same as the last one. You have to do some minor operations. Big thing here is just remembering your order of operations. Parentheses. You'll add these 2 first. So add your i's and j's. Oh, excuse me, these 2. And then you'll find the dot product. So let's look at 11. What comes first in the order of operations? Multiplication or addition? So first thing I have to do is find u dot v. 2 times 3 is 6. Negative 1 times 1 is negative 1. Plus u dot w. Negative 2 times 1. Oh, excuse me, positive 2 times 1. 2. Negative 1 times 4. So that's 5 plus negative 2. So the answer to this whole problem is 3. Just remember your order of operations. Here, you're going to find your dot product first, then multiply it by 4. Here, you'll multiply 4 through your vector first, so that'd be 8i minus 4j. Then you'll just dot it up with v. You'll get your dot on. Sorry, what's that? Questions about what we're going to be doing on that slide? Only 2 left, and only one of them is a work problem. The other one is a formula. Write down this here formula, the one I've rectangled. Well, they're the same thing, but this is like after you, because you're solving for theta. So they just went ahead and said, so basically theta is cosine inverse of that. So it's the same formula, just one step further advanced. To find the angle between 2 vectors, you just take cosine inverse of their dot product divided by the product of their magnitudes. Cosine inverse of the dot product divided by the product of the magnitudes. So it's smart for you to start every time looking for the dot product. Oh, and by the way, I'm sure this is something half of you probably already figured out, but if the dot product is 0, you know, that's going to give you cosine inverse of 0 divided by something, which is 0, and cosine inverse of 0 is 90, which is why if you get a dot product of 0, they're orthogonal. Again, let's say you don't recognize that and you finish the whole problem and you have 0 divided by 50 and you get 90, bing, light bulb, and you'll never forget it again. Okay, let's find the angle on 17. First thing you need to find is my dot. 2 times 3 is 6. Negative 1 times 4, negative 4. So therefore my dot product is 2. Now I need to plug in my magnitudes. Magnitude of the first one, 2 squared plus 1 squared, that's 4 plus 1. That's square root of 5. Can you solve it? That's a 1, not an I. Square root of the second one, 3 squared plus 4 squared. What's that one going to be? Regular 5. So that's radical 5 times 5. And you'll punch this straight into the calculator as is. Who was the last person I loaned this thing to? Did you bring it back? Okay, so here we go. Second, cosine. Oh, make sure you're in degree mode. That was almost a close one. Second cosine of 2 divided by 5 times the square root of 5. The nearest tenth. So 79.7 degrees is the angle between your 2 vectors. 79.7 degrees. Excuse me? Oh, yes. Yes. I don't know. What did you get? Well, I could be wrong. Let me check. Well, that's possible. Tell me exactly what you punched in, like verbatim. Cosine inverse of, then tell me all the parentheses and everything. Okay, I'm going to stop you right there. The reason you got that is because it's doing order of operations. It did 2/5 times this. See, on mine I put the denominator in parentheses, so it knew to divide by that entire quantity. Try inserting a parentheses there and see what you get. And I'm glad that happened because that's going to happen to a lot of people. The problem with punching these things in, is it work that time? Is all these parentheses, which is why it's actually safer to do it like this. Do the actual math portion, so that's 2 divided by the square root of 5 divided by 5, second cosine of that. That way you don't even have to worry about parentheses if you just do it one step at a time. but it's up to you. Questions about where any of those numbers that you see on the board right now came from? You see if you can bring it up. Questions about where any of that stuff came from? That's the last slide. We've done everything now. The other one was, are they orthogonal? And that's just where you take the dot product and see if it's 0 or not 0. Fantastic. 2 sections done. Okay, I'm obviously changing these problems because you have 2 sections worth to do. So the first one is actually page 7. Oh, what? Yes, on a Friday. We've only got one more day before the midterm, so that's too many O's. You have your O face on. Really? 2, 6, 10, 30. There you go. I think that's how it's going to work out. There you go. Oh, the torture. I should probably stop recording. Yeah, I can't find my remote. No.